Okay, so we have this logic here, right? And we need to find the BigO notation for this. With that too in the time complexity. When we say time complexity, I told you we'll just look at the number of operations we are performing. So look at this, right? We are passing n or m, right? We are not pass. This is right. So someone can provide n as 1, 10, 1 million, right? Whatever they want. So we have to see like what is the logic which is happening inside this. First of all, you it is very clear for me, right, that you are anyhow using for loop, right? And we talked about whenever using a for loop, the complexity of this you can assume like it would be n, right? Just also see this part, right? Till what loop this will run? It is running till n. If it is 1, it would be 1. If it would be 10, it would be running 10 times. If it is 1 million, it will be running 1 million times, right? So it means that it is following that linear graph of the big notation. So you can consider, right, this to have the complexity of n. Okay, complexity, the number of operations which you are doing is n. Then let's see what are the other operations we're doing. So this is one operation, n plus 1. This is one more operation, n plus 2, right? And if you would see, right, this is also now again an n number of operations which are happening, right? It could be any value. So it is n value, right? So now let's try to find this. So n plus n plus 2. So it is like 2n plus 2, right? And I told you you should ignore the constant values which are you adding. So remove plus 2 from there. And then when you now you're left with 2n, right? When you are left with 2n, just skip the 2 part from it, right? Now what you get the complexity is the complexity of this the time complexity of this program is what? N. Let's see this. N plus m, n plus m, n plus m, right? Okay. If you see this, right, they have given the explanation as O n plus m time, right? But we will not be saying this, right? See what we are doing is where is our board, right? See this. Uh, Let me copy paste that code. Next. Hey, hi, Priscilla. Good morning. Right. So we are trying to what we are trying to do today is we have learned about time complexity, big notation yesterday. We are trying to solve some questions and trying to write the big notation for them. Okay. So and right. So we have to write the big notation for this program. So what I told is since you have this as a for loop, right, you can be sure that it will take n number of operations. Similarly, if you look at this, right, this will also take n operations, but since the word m is used, you will first use m, but I'm telling you you should write it as n, right? Like this. What are the other operations you are doing? Number of operations. This is one operation. This is one operation, right? So let me write how many operations I'm doing in total. If you write with the terminology of m plus n, right, you will say m plus n plus 2, right? But I told you ignore the constant part, so remove it. Okay, remove this part. So now you're left with m plus n, right? Now let's consider that the value of n and m are same, right? Let's say. So what will you set? What you will see n plus n. What it will become? 2n. And I told you you do not have to worry about these things, right? Just say n. Okay. Now what is the complexity of this program? It is n operations, right? So what is how will you write this? So complexity of this function, right? Of this function, right, with n number of inputs, right, is what? It is O of n, right? And how does O of n looks like in a graph? It looks like this, where n is the number of operations which you will be performing it. It is the number of this is like the big O complexity, right? The time part of it, and here it will be looking like this. Okay. Now, right. So so what is the time complexity of this program? It is O of n, right? Now you may, as you were seeing here, right? It was saying that the big notation for this program is what? Not this one, sorry, this one. You can see, right? I think it will say the output is O n plus m time, right? But again, if someone is very specific, like give me the exact value of it, then you can show them, right? Okay, then this is what it is, right? But if you show them the complete process, like which we did right over here, which we did over here, right? They will understand like what you are coming on, right? So if you say NA, right, it's not a wrong answer. It's a right answer. Okay. Whenever you're finding a big notation, you have to generalize the thing. It should not be like you should be very specific. Okay, it is 2 and 5 and 10 and even if it is 5 10. Okay, let's understand this, right? Why I'm saying this. See, let's assume that n is 1 million. Okay, let's assume that number of, I mean, the value of n is 1 million. 1 million, 10 lakhs, right? Now, if you say that your operation, right, will take 10 lakhs, right? 10 lakh plus 2. First of all, let's come to this part, right? It is negligible, right? So you can ignore. So this part should be very clear, right? Why we are ignoring this? This is gone. Now let's come on this part, right? You are saying n 10 lakhs and you said 10 lakhs plus 10 lakhs, right? 10 lakhs plus 10 lakhs. Okay, it becomes 20 lakhs, let's say, right? Right? How does it matter? How does it matter? Like, what is the complexity here, right? I mean, how does it matter? Like, if it is 20, 100, 1,000 or what, right? It does not matter, right? It does not matter because again, the if you're doing 10 million 1 million operations or you're doing 2 million operations, right, it does not matter in a way because the complexity of this is getting defined that it will take much time, right? We are reflecting it over with the n also, right? Because it's a linear operation as per the mathematical equations, right? Now, but what would have been a difference here if this for loop, right, if this for loop was inside this, right, if this for loop was inside this, right, in that case, right, it would not be m plus n, it would be n square, right? N square. You are you're doing it, you're multiplying it, right? N into n. Okay. Now this changes the equation, right? If you look at this, right, it's a linear equation. It's a linear equation, right? And a linear equation looks like this when you draw it in a mathematical graph. If you have a constant value will look like this, right? Like this, something like this, a constant time value. If you have a quadratic equation, right? Quadratic equation look like this, like a steep growth, right? It means that if you increase the value of n, right, by even, let's say here the value was 10, the value here was 100, right? It was 1,000 here, right? So see, at 10 it was still negligible, right? But at 100 it exponentially increased, right, by the power of 2, right? And when you have 1,000 inputs, right, it again increased to a very good extent, right? The time required to solve it, right? So that is the problem, right? So again, you have to understand that if you understand these graphs well, right? For a linear graphs looks like this. For a constant graph looks like this. For a quadratic equation, graph looks like this, right? So the entire graph is this for n square, right? If you would have learned the equations in maths, right? Uh, if you have an equation like this, x square plus y, right? If someone asks you to draw a line for it, right? A graph for it, the graph will somewhat look like this, right? Based on, because this is the bigger power, right? This is the bigger power, it's a bigger power x square, right? So your graph would be controlled by this equation of quadratic, right? That square position, right? So in this case, if you, let's say you found that you have a logic like this x square, right? You have a nested loop inside this and also this loop. So how would you write it? I am saying for a nested loop, the big O notation for this becomes n square, right? N square. And for this it is n. So now it becomes n square plus n, right? Now you have to understand, if you compare this value to this, right, it becomes negligible. It becomes negligible. So you don't have to specify this. Okay. What you will write is you will say n square now. If you have three nested loops, right, one inside one and then one more, right, what will be the complexity of it? N cube. And if you have n cube, n square has no chance to be, I mean, it is negligible as compared to n cube now. So what you will say is, what is your big notation? N cube. Are we getting this? Fizula? Okay, great. Sudhakar, I hope this is clear, right?
Yes, sir.
Let's try some more questions, right? Let's try some more questions. What is the time complexity of this Java program, right? If you see this, right, you have a nested for loop here, right? Let me copy this, right? Okay, not now you tell me what will be the value of the output here. You can see it is controlling by the power of n. Okay, Let's just, okay, let me grab this and add it there. Let's try to find it out. And please keep in mind that what we'll do now from now onwards is every program which we'll write, right, we will try to find the big annotation of that program, right? Whatever we'll solve. And till now, we have not learned about logarithmics value. We will talk about them in the later part of our course, right? Because it will require for you to understand recursion and the sum of the searching and sorting algorithms. I think there I can show you the use case of that logarithmic value. Till now, let's just focus on this part. On only three: the constant value, which is O of 1, a for loop O of n, or a nested for loop or chain of nested for loops, right? Which will increase the power of n by as many for loops I had. Okay. So over here, if you would see, let me just create int n, right? So now program is valid. See this value of, so how many operations? Let's start counting. Right. Let me grab this again and put it here in our board. Text. Okay. And let's understand this. How many operations? Tell me. Sudhakar, you tell me. How many operations do you see here?
Two operations. Like,
Okay, tell me which where should I tell me the count? Let's do it. Let's count every operation. So tell me. So is it an operation?
yeah, yeah. First one,
It's an
initialize also.
it's an operation, right? It's an assignment
Yes.
operation, right?
Oh,
So
yes.
how many times we'll be doing it when we run this method? Only once?
No, n times.
No, this will be running only one
Oh,
time,
yeah,
right?
one time,
One time, right? So it is one operation.
one
Let's
operation.
go to the for loop round, right? You can see the for loop will run n number of times, right? Depending
Number
on the
of
value
time.
provided. So
Yes,
the this part becomes what? N as of now, right?
n
Right?
times.
This is n part. And if you look at this, right, what is happening here? We are saying int j equals to n. Let's say we provide 100 as n, right? So it is 100 here. It becomes 100. So j is becoming 100. And j has to be greater than I, which becomes what? Which becomes 0 in this case. In the first case, right, value of I is 0, n is 100. J becomes what? J becomes 100 there.
Right.
J becomes 100 there. J becomes 100 there, right? And what else is? J becomes 100, and we have what? J becomes 100, I and J, and I equals to 0. What we should say here is, okay, yeah. In the first iteration, let's start writing. Right, in the first iteration, the for loop, the first for loop will have the value of 0 to 100. Right, it will run from 0 to 100, and within it, what will happen is the J value is from 100, and it will run till it is greater than 0. Right. So we are doing this. In the second iteration, what will happen is, okay, this is greater than 0, right? So it will happen this way. In the second iteration, it would be what, 100 only, and it will be running till 1. In the second operation, it will be greater than 2. It will run till 100, greater than 100, right? So how many operations are we doing here? N operations only, right? You can see,
Yes.
right? N operations only. N operations are happening here inside this loop also, right? And this is also N here, right? So what you can say is, I told you, if you are performing N operations in an outer for loop and inside the inner for loop, right? You can, you have to say it as a combined value of N square, right? N square. So now the total number of operations becomes what? N square plus 1, right? You can ignore this part. So what you will get? N square, right? Let's go and check the value. You see, right? O n into n, right? We understand this part, right? Or no? Ragar?
Yes.
Right? Okay. Shukla, I hope this is okay with you also, right? Okay. Right. Let's move ahead. Let's, what is the time complexity of the following code? Now, if you look at this, right, it has a code like this. Let me grab this and place it here. This is public void m3, and we have this value, and we will say int n, right? And I think we're good. Now let's look at this. We grab this again, and here what we'll do is
But
So
in
this is
second
for
case,
log, right?
we have second for loop, right? It will run first for every iteration for first loop. It
uh,
will run n times, right?
we'll run
Almost
n
n
times,
times next time,
right?
n minus 1.
Right. See, always think from the perspective that you have to generalize it, right? You do not have to find the specific values, but yes, go on, right? Yeah. Tell me in the second iteration what will happen. How many times this loop will run? Let's say the value of I is 0 here, right?
Yes,
Value of I is 0. How many times this will run? 100 times.
yes.
Once the value of I becomes 1, how many times this is running? 99 times.
99 times.
When it becomes 2, it becomes 98, right? So
Yes,
try
yes.
to understand how many times this for loop is running. N
N
times
times.
only.
N
N times,
times.
right?
N times.
N times, right?
Yeah, you got it.
Right? And similarly here, right? On the above. And within the for loop, if you start counting, right? What all we are doing this operation, we are doing this operation, right? We are doing this assignment operation, right? So again, right? You do not have to go into the specific parts, but just try to understand that how many times the for loop will run, right? So you will be able to, able to find the big notation very simply. Okay, in a simple way. So we are okay with this right now, right? It should
Yeah,
be n
got it.
square for this part. For
Yes.
this part, let's go here and copy this and whiteboard. Let me paste it here. And let's just going. So we have this part here, and what we are saying is, uh, this is one operation, right? Like one, two, three operations, right? There are three operations happening here. Three, let's say, right? Then if you would see, it is saying I n by 2, right? It says I equals to n by 2. So it is starting from the half position, right? So if you provided 100, n as 100, right? And you have n by 2 becomes 50, right? So what you're saying is your loop is starting from here to here, right? So it is saying n by 2, I less than equals to 1, right? So this loop, the outer loop will run how many times? Let's say n by 2. As of now, right? Let's say n by 2. Can you write this as 0.5 n? Right? We can do this. Afterwards, right, what we have to do is, if you look at this, how many times this is running? It is running from j equals to 2, which is a constant value, and it will keep on running till the value of n, right? Till the value of n. So this will run how many times? This will run almost n times, right? N times, right? But since you are increasing the value of, you are setting the value of j and multiplying by 2, right? So what you're doing is you're multiplying it by 2. So how many
This will
operations
go
you
in
will do?
terms
I
of
think n by
log,
2
right?
only, right?
No,
Sorry,
this will go in terms of log, right?
is going to the log.
Because it is doubling each time. So each time when it doubles, it becomes log, right?
Right. And we have not learned about logs, right?
Yeah.
Okay. So again, okay, let's leave it as of now. Okay, I don't want to discuss that log part today. So okay, let's go back. Where is the question up? The question. It's the question, right? Right. Visualize right. It will be this doing this, right? But since we have not talked about this, let's not discuss it, right? Let's take the simpler case. Uh, Again, this is for login, so it will not make sense as of now. No, let's talk about this. This seems simpler here, right? What will be the time complexity of the following code? Let's grab this and let's talk about this thing. public void M4, and it would be int n, right? Let me grab this, and let's see. Okay, so we have is this. How many operations for this? One operation, right? It is running n times, right? This for loop is running n times, and this is a nested loop, right? So it is something like this. So this is I equals to 0, I equals to, so it will be running n number of times. How many times this will be running? 0 to I. Okay. Now, when I is 0, right, it will run one time or 0 time. When I equals to 1, it will running one time. When I equals to 2, it will be running two times, right? And so on, right? It will be increasing in this way. So again, it's not linear, right? Every time it's not fixed. The for loop over here, right, will run depending on the value of I there, right? So, but again, let's try to write this. How many operations are we doing here? We are doing one operation here, we're doing one operation here, one operation here, and this can run depending on the value of I. See, what I will write here is I will still say the value. I mean, this is equivalent to n only, right? Because you're doing all these operations, and if the value of n increases to 100, or let's say 1 million time again, right? 1 million. So this for loop will run 1 million times. Okay. So at least from my perspective, I feel, again, I'm not going to the specific values. So what I will still say is that the value will be n square. Okay. Let's see what they have provided. Okay. Now, if you would see, they have given the output as n minus 1 by 2, right? Now, again, we are not trying to be expert on math. So let's just take their case. They are saying n minus 1 by 2. Let's write it. N minus 1 by 2, right? You are multiplying this, right? So let's start multiplying. N square, right? N square minus n, right? This is what they did, and they are dividing by 2. So what is happening here is it will be n square by 2 minus n, right? You can treat n2 as what? 0.5, sorry, 0.5 n square minus n, minus 0.5 n, right? Now I told you, right, when you're writing in this way, right, you can, when you look at n square, right, you can ignore the other value, right? So I'll ignore this. So this will be what? 0.5 n square. Now I told you to ignore the constant values also. This does not matter. What is the output? N square, right? So again, please, I mean, it is up to you whether you want to go into that detail, but I don't think it is required. But because for writing these equations, right, we'll have to start solving our mathematical equations, which I don't want to do, right? And I don't know, like, whether people would be interested to know that also in an interview case. I don't know. Fizula, what's your point on this? Do you think like we should get to a specific answer like this, or is it this is fine?
So they just asked like how many times, what is the space and time complexity? So we can just tell these are the loops we are using. So this will be the final answer. They won't look behind the scene. So I will
So
fix
we
n
are okay
square
with
or
n
n
square, right?
log n. Yeah, the direct answer they require. They'll just ask the space complexity and time complexity. So it's just a one line of answer you have to give.
Right, right. Okay, thank you. So now, so we are good on this approach, right? Which we are taking, right? So the time complexity for this program is what? N square only. Okay. You can solve the output which they have given, and this will turn out to be this only, right? See, when you said n square, right, you may say, Akhil, if you, let's take this, right, n square, n what, n minus 1 by 2, right? You will say, Akhil, if value of n is 1, what will the value of this? Let's say the value is 1, it will be 1 1 minus 1 becomes 0, right? So 1 into 0 divided by 2 becomes 0, right? Okay, fine, right? If you give 100 value, what happens there? It becomes 10,000. It becomes what? 10, 9 divided by 2, right? It becomes what? 90 divided by 2, right? I hope I'm doing it correct way. Oh, I took 100, right? It should be 190. It should be what? 9,000 divided by 2, right? It becomes what? 4,500? 4,500, right? Now imagine, right? You provide 1 million. What will happen here? It will become 1 million 10 to the power 6, right? And you are multiplying it by square, it becomes 12, right? Similarly, if you do this, right? So it is 10 square, right? Maybe here when you do the operations, it will come out to be what? Let's say compared to 10 to the power 11, it will come to like this, right? Or let's say it becomes this. Does it matter? Does it matter if it has 10 to the power 12 as compared to 10 to the power 11? No, right? We don't. It does not matter for us. It has already reached a value which is too much, right, for us, right? And it is following a pattern of n square, right? Right? It is following the pattern of this, right? N square. You gave the input of 10 6, right? And I said square it. That's why you were getting this, right? Whether I write 10 is to the power 12 or 10 is to the power 11, it does not make a difference, right? That's why we are saying don't go to the specific value. Just try to find the a generalized output of this big notation. Okay.